Okay. Do you hear me okay? Yeah, cool. Right. This will be a bit different. Well, firstly, my name is Matias Piipari. I'm CEO and co-founder of a company called Manuscripts App. We build basically writing tools for research scientists. I'm also involved with another company in the same field called Papers App. And Papers is basically a reference manager that handles, like, organizes and lets you read PDF documents. It's a big library of documents that people would typically have to deal with when they write their PhD thesis, for instance. It could be thousands of PDFs, in some crazy cases even tens of thousands. And it's a very popular tool. We got the Apple Design Award for it some years ago, and everything's going fine, except for syncing. So syncing was the reason we started looking at Couchbase Lite some years ago. And meanwhile, I got started with this other project, a spin-off of basically that product. So what I'm going to talk about today is basically two things. Firstly, I'm going to give more of a case study on why is it that we went with Couchbase Lite, some example rationale for that. And the second half is going to be about some contributions back to Couchbase. So we've really had a good experience with Couchbase Lite, and I really want to thank for the opportunity to present here. And also, I've just pushed the GitHub open source button a few hours ago on a piece of open source code that is kind of linked to this talk as well. So nice moment in that sense. But yeah, you may be wondering, word processor and Couchbase, what's this about? Like, I'm actually writing a word processor tool with a Couchbase. Yeah, so to give some indication of why we're using actually a database product behind this is that we're treating writing as a more structured problem than for instance, a word processor typically does. So for instance, the sections on the table of contents are separate objects or separate documents in the document tree. Or individual paragraphs are actually kind of snippets of certain kinds of markup in there. There's all kinds of other kind of structured objects inside this document that we also want to, for instance, synchronize and merge across different devices and different users' version of this. And one very obvious case of why we started thinking about something a bit more structured than like building everything from scratch ourselves was that we wanted to build a template library of multiple thousands of different documents in here. So when you're writing a scientific paper, it's very common that you would have to follow quite a lot of different guidelines from the journal. And we wanted to really help with that problem by building templates that actually tell you that whether you're doing certain basic things right or wrong about that writing project. For instance, word counts. We tell you whether you're highly above the word count or what are the section names in that document. So we're modeling those templates actually as certain kinds of Couchbase documents in our code as well. But yeah, there's thousands of them. We're building far, far more. And actually, one of the other targets in this project has been building a tool for building those templates. And actually, so that tool and a couple of other bundling tools that we created for it were the reason why we started actually then thinking that, hey, actually, there's something a bit more generic here. Let's build it in a way that we can actually then open source at the end as well. Okay, so to go back from that template, so what you're looking at here, for instance, is those placeholders are coming from certain kinds of smaller components inside that template or the section headers on the side. One of the major reasons why we started looking at Couchbase in the beginning was that we're going to use WebKit. So we're going to use, it's in fact not a Cocoa application, it's a Cocoa WebKit hybrid application. The editor on the right-hand side is in fact the WebKit content editable, editing the document. So in fact, behind all of this, we're using the HTTPListener from Couchbase for basically getting the data that we then render inside the editor view. I'm going to tell you a little bit more about the architecture behind that as well, but that has turned out to really work really quite well for us. So the previous talk and some other talks in this meeting have concerned using PouchDB for kind of PouchDB in combination, for instance, with Sync Gateway or in other forms. We could do that as well. We actually started that project at the stage where PouchDB was still in its infancy and we used something else for it. But yeah, very, very similar kind of concept. So our architecture actually on this level involves having like a package of different databases. So we have, for instance, on the manuscript's contents in one database, the author name and affiliation data, like the bibliography metadata for the authors who are writing the document in one, and then like the larger, like the citation stuff that you're citing from external documents in another database. And I'll get to why that makes sense. It does. But another thing that I wanted to represent on this diagram is that we've got different kinds of interactions between these databases and what we have at the top of the screen, like the web-based model for it, so that the data that we are, kind of the view of this data that we're updating using the HTTP listener, like getting data or watching the data using the change tracker feed of it. So for instance, the contents are being manipulated by the web-based model. So the contents are being edited by the WebKit-based part of the application. But for instance, the author name data is only being presented by it. So we're just pulling the most recent version of that into the editor and then presenting that. And the reason is that it just happens to be much nicer to bring the author editor tool as a native Cocoa component. So we built that in using, let's say, you can get your contacts from the address book because your co-authors for your paper probably will have exchanged emails with them and you know their names. And it's just overall a much nicer experience to give. And it was probably maybe 15 minutes of work to get the author list presented on the WebKit side based on that data kind of being pulled over from through the change tracker feed and so on. The same thing with the citation data. So we've actually got a citation processing engine that is running on the kind of the native code side, and we're really just presenting its results in the WebKit editor. So we have, in fact, two different data models, one in the JavaScript side, which is a subset of the full domain model that we have, and then one in the Couchbase Lite, the feather side of this, that is driving the Mac-based UI for it. Now, another area where we really wanted to kind of make a difference compared to how word processor tools like, let's say, Microsoft Word or these kinds of things work usually is that it would be great if you could actually collaborate with a native application sitting on your desktop. You could send, let's say, a copy of your document across to your collaborator or your supervisor, and as usually happens, you get the feedback back in about a month, and you've been actually since editing. So if you do this with Word, you end up actually manually merging all those changes back. And obviously, Couchbase with the version tracking and the change feeds and the replication is a great match for that. But I've also put some unusual icons in the background here. So we're actually not yet using the sync gateway because, well, firstly, for this project, our investment that we have, investor who is involved, what we've got funds for is basically writing this native application. We haven't really accounted yet for instance, the server-side infrastructure that we're going to have to build for doing the collaboration in larger form using the sync gateway. But actually, Couchbase actually has a second way of synchronizing built in as well, in that you can just bring up two of these HTTP listeners in two alternative versions of your database, pull from one, and then you've got all those changes kind of, and then merge the changes and put your version back onto the drive that you, for instance, a Dropbox version of your manuscript or a Google Drive version of your manuscript that you've got. I can explain a little bit more about that maybe as well, but basically this is our approach. We want the user to really own the data even at the stage where we're not really focusing on the collaboration case yet. So we want the user to be able to do what they want with, let's say, sending the document in email, putting it on Dropbox if they're already using, for instance, that kind of tools for collaborating with their co-authors. And this actually has a second kind of longer kind of strategic point about it, which is that we can now tackle just this problem more with like the user experience and just getting a complicated writing tool right, and then look at the collaboration at the stage where we can already support, let's say, small group collaboration or syncing that data. So the point here is just that sync gateway is great, but there are weird projects like this where actually at the prototyping stage or at the very early product launch stage, you may want to actually just even disconnect yourself from that or postpone using something like that. Another thing that's worked out really quite well for us is the CBL model, like the domain model tools that are available in Couchbase. I'm going to show some examples of how we've extended that or kind of made certain conventions on top of that that have helped us with it. But yeah, so our model includes something like 50 different entity types, quite a lot of relationships and subclassing between them. Another aspect that was clear already from the early on, and what I kind of showed you already with the template screen, is that we bundle a certain amount of data with the application. So with something like 30,000 documents, plus some of them will have attachments with it. We wanted to keep the binary size quite low. So anyway, so it's something on the order of 60 megabytes of data that is actually bundled with the application, citation styles and templates and that kind of stuff. And to actually put that together in a form that is easy to maintain, we also had to build a bit of tooling, and Couchbase Lite was great in that, but yeah, we built something on top of it. So the idea is that you've got, for instance, some JSON files or JSON files that act as your data source for the data that you want to bundle with the application, and we have a certain tool called Stapler, which staples these files together in a Couchbase Lite database. We bundle that database together with the application and either replicate from it or just copy it into like an application support folder. So that's the form that the templates took us. And another aspect related to this data bundling is that in some ways you can treat that data as just as a starting point for something that we might then want to crowdsource. So let's say somebody writes a paper for Nature, and using the template that we provided for Nature, but they find, let's say there's a typo in some of the placeholders, or there's some information missing, or Nature has changed their guidelines in some way that what you have to send them. It would be great if the user could actually submit that information back. And obviously that is possible because you've got a version history of, you know, this was the original revision that I got from the application. These are the edits that I've made to it. So we could actually use also Sync Gateway as a form of, let's say, receiving updated data from the users back to us as well. And we've also, although we're launching this product now, firstly as a Mac application, as a native Mac application, because our existing user base is so strong on the Mac because of the design awards and stuff. So we're only dealing with Mac right now, but we're obviously, if this goes all the way to the same scale as what Papers has by now, we're going to have a Windows version, an iOS version, a web platform, and all these things connected to it. And so that's another thing that we wanted to really take care of. Like, a lot of people will build, for instance, in this space, applications using core data, and then they're going to be stuck with that schema. It's not nice writing a Windows application based on core data based schemas, for instance. Anyway, just to outline some of these things that I've now spoken more in terms of the rationale that we used for choosing Couchbase. So firstly, allowed us to serve the data and its change feed over HTTP to this WebKit-based part of the application. It's really helped us focus on delivering a great offline experience. It really is literally offline. There's no like a connection, like the persistent connection to any kind of server there. The object document mapping and attachment side has been really helpful, and that's what I'm going to go into in some more detail now. And in terms of syncing, what we've really been able to focus on is just we've been able to treat it as a conflict resolution problem and making our UI robust to a model that may be in some form of sort of intermediate or inconsistent state. Let's say I've synchronized some data over, but not everything. I need to be able to present some, hey, this stuff is still missing or coming over. And that's a big part of it. We haven't had to deal with any of the mechanics of it like we have with Papers, which has its own syncing engine. And then it's wonderful that we've got this control over the data. So both the user and us as a vendor can think that we have control over this. It's not like, let's say, parse or some of the other options where you're kind of stuck with the data on somebody else's platform. Yep, cross-platform. And specifically in the case of Mac applications, so that there's not much that we've thought about, let's say, okay, so this is a Mac application, how does this differ from the iPad actually? So for instance, the same low memory footprint, fast startup times that you get from Couchbase Lite have been really the same case on the Mac as well. And some of the runtime performance drawbacks that you do get actually from Couchbase, those have been actually less of a problem on a Mac case. But yeah, actually one thing that really struck us only like about a year into the project is that it actually also is a very healthy open source project. So it's been basically every single time that we've reported a bug or some feature request, there's a response, even let's say Sunday morning on the same day or within the few days. And that's actually one of the reasons that I wanted to really just also give this talk and open source some of the parts that we really contribute back. Okay, now the second half of the talk then. not everything is rosy. So I've been talking with some other people who are familiar with Couchbase Lite as well, and kind of trying to gauge of why is it that they haven't, for instance, stuck to it. And things are a bit, I would claim that actually one of the primary reasons is that things are just a bit different. Indeed, like I just had this funny conversation with somebody who was kind of ranting at me in a meetup that, hey, well, everything has to work so differently. But so, for instance, you've got differences if you're coming to this from a relational database side. That let's say your data modeling is totally different, your data querying is totally different, the consistency model is different. Validation is something you have to think about yourself in a very domain-specific way, and you've got different kinds of performance bottlenecks to worry about in a mobile setting. Anyway, the list can go on and on. I'm not sure I agree with all of that really, of how hard it is to adapt, but yeah, a lot of people haven't, I guess, yet. And I'm not saying actually the Feather is in any way a response to all of that, but it is. What we really wanted to do with this is, on top of Couchbase Lite, is to speed up some of the recurring work that we've had to do, and impose some structure and conventions that have proven quite helpful once we've been able to build a couple of different build targets in this project and different kinds of UI tools and command line tools on top of it. So to outline what we've done, so firstly we've tried to help with the process of kind of partitioning your data into multiple databases that are bundled together in some form. So if we want to synchronize this data peerlessly in a form where we put, let's say, I've just put my manuscript on a Dropbox drive, and it's now changed. Not every change should really invalidate that copy and result in all my other clients looking at downloading that version and checking what's changed and pulling from it. So if we partition the data into these smaller sections, let's say if I introduced a new citation, that doesn't mean that the content has actually changed in the document in any form. So only my citations database needs to be synchronized over. Or the same thing with the author metadata. So we kind of built these kind of islands of smaller databases for that reason. Another thing that we did quite early on is to start managing our data in kind of these repositories. We have dumb data model objects, and then we've got repositories that do the CRUD operations, and then we've got some services that, let's say, do some more complex operations and manipulations on them. But just the act of, let's say, here's a model class, here's a repository class, here's a service that deals with it, that ends up already taking a bit of time sometimes. So we have a certain solution to that problem. But then one of the powerful things about this kind of document-based database is, of course, that you don't have this limitation of like tables. Like I could have, or let's say, inheriting similar kinds of behaviors for completely unrelated objects in how they're kind of the equivalent thing of like single table inheritance that doesn't exist. So we actually have built some mixins for like support for mixins for adding, for instance, certain kinds of behaviors. Let's say certain kinds of objects in my database will have a title. I shouldn't have to really go and implement all of these things in all my classes separately. So that's maybe a bit contrived example of one property. Of course, it's the same amount of code if I just go and declare the property, but there's more complicated cases than like that we've been able to solve by putting in, let's say, being able to describe that this class consists of a couple of unrelated mixins that deal with some parts of the data model that or data that is stored in the database. And yeah, this tooling for pre-computing data that's shipped in the app. So, oh, that doesn't actually work on the screen size. Okay, here's a diagram explaining some of the kind of higher level idea of what does a Feather kind of database layout look like. So we've got like a separation of data that is sort of shared between all your documents or well, documents in the NS document or UI documents, and so between the different files that you're editing with this application. So you've got the application support data here. So to give you an example, here's a funder database, there's a template database, there's a styles database inside there. So this is shared between all the different files that I may be opening with it, and if I make a change there, that shows up in all my manuscripts. But then, and each one of these files that you're editing is in fact like a folder that contains a couple of different databases inside it. So in this instance, I've got a conference abstract and a thesis database inside there. And this database then contains distinct sets of data, like for instance, something that is managed by a sections repository, some things that is managed by a paragraphs repository, a styles repository, and so on. And one additional layer that I wanted to show here as well in this context is that if my paragraph style, for instance, here is a model object, I've got a margin definition as a kind of as an embedded sub-object of it. So it's kind of the same thing as what the Couchbase Lite for iOS supports in being able to have like CBL JSON encoding properties, and it figures out that, hey, this is actually another model object. So we've actually built this before that existed, when it was still TouchDB and so on. But actually, there's some additional features here, like for instance, you can actually have dictionaries or arbitrary collections of these embedded objects, like nested objects here as well. So I could have, let's say, an array of arbitrary embedded objects that is encoded inside the document of this paragraph style object. Quite a powerful concept, actually. One of the things that we use it heavily for is trees. So there's like a wider tree structure that is stored inside the document, and there's a nice model for it. Okay, just to outline this again. So the model, we like to keep that very dumb, and to be able to do that easily, we introduced this kind of object controller for all the objects. So each one of the entity types actually has a corresponding kind of repository or controller type. There's an implicit connection between them, so that, for instance, if I got a class called X, which is a model object, then X's controller is implicitly its repository. You can override that stuff, but we've had a couple of these conventions just included through some runtime magic, so that you don't have to write the boilerplate for this kind of thing. So if I have one of these like database package controllers, I just put into it a X's controller, and then whenever I make, for instance, queries that result in types like model objects of X being returned, then it kind of automatically knows that its X's controller is the thing that it needs to be concerned with it. We also have some defined observer callbacks for this model updates. So for instance, did add, did update, did delete are implemented in some of the base classes for this. So both the repository and the model object will get these. One of my personal favorites actually out of this has been also that we've got certain prefix properties that have some defined behaviors. So for instance, if something is prefixed but cached, it means that this is going to be treated as a kind of derived state that can be wiped out when the data changes. So if I've got my model X has a property Y, and I've got something that is derived on that value of Y, then whenever the database changed, I'm going to wipe out this value of that property out. Ends up being quite a common thing to do with this kind of database, because you end up doing some operations on top of your query results, for instance. Quite often you would do some extra sorting or extra filtering in certain contexts, much more so. So like for instance, the live queries are great for this purpose, but they didn't, at least in our application case, they didn't quite solve the complete problem. And yeah, then there's also this convention of if you've got something that is prefixed embedded, then those are expected to be embedded objects of some kind. Like let's say it's a collection of embedded objects. Now I mentioned that this is all based on certain runtime magic, and people have different kinds of opinions on how sensible that is. I'm of the opinion that it's fine as long as you fail very early. So if we, for instance, have a certain convention that you need to have an X's controller, if you've got this model type X, you're going to fail very, very soon after class initialization when you run this application, so that you don't, let's say, ship this thing with flawed kind of property names and so on. So we try to be quite careful with that. But yeah, so embedded objects, I'm going to go into a couple of these in some more detail. You're going to find some more examples just in the test suite for this framework as well. But embedded objects, so they're like nested in the containing objects JSON representation. So very, very similar to the CBL JSON encoding, except that you have more control over what kind of collections they can be included in. And if I make, let's say, I've got a tree of these embedded objects, and I make a change in one of these leaves, the changes are actually propagated back to the containing model object, so that I know that, this is dirty and I need to save it sometime soon. So just explain this again. So you've got a bibliography database that contains a citation repository for citation objects, and then a citation itself contains embedded citation items. So a citation item would be like one component in it. Let's say I'm citing these two different papers in the same citation that we've modeled with these embedded objects, because this citation item is not relevant in any other context, but inside that, the citation item is not relevant in any other context, but in the context of the citation that included it. That's what it looks like on level of code. I'm not sure that is needed in any more detail. We've got some query helpers as well. So just so that you can, basically in one line, deal with the common case where you've got a view that will have require, for instance, the prefetched key, prefetched document in it. So you can do that very quickly. Yep. So we've got also this idea of this object graph changes. So I mentioned that we've got a convention on these being named in certain ways. So you can implement like notification observers with a certain notification center category that we have for, let's say, I want to be informed when X changes. So that means that then I need to implement did add X, did update X, did delete X. Where we've tended to be in our design quite against kind of KVO, tends to result in nasty things. This is a little bit easier to debug often, that you find that, hey, you're missing this method called did add X instead of getting hooked up in some weird KVO callback. Anyway, and then we've got this idea of this automated cache kind of busting that's based around these updates as well, baked into the repository and the model objects. So for instance, I've got a styles controller here, or a styles controller which has a property called border styles, which is populated by a method called styles of class that ends up doing a database query. Let's assume that that is very costly, and that this border styles is being accessed often. So then I can just define this property in this manner, and I don't have to write the code that actually clears the cache when anything in my styles database changed. There are cases where this is too heavy, of course. Like, let's say there are regular changes to border, like some styles that are not border style objects. Then I can go and kind of override that behavior. In most of cases, that hasn't really been that necessary. Right. Another thing that may be useful for other kinds of applications than not just us is this idea of cascading object lookups. So I mentioned earlier that we've got this idea that you've got like file-specific databases. Let's say each of my manuscripts will have some databases, and then there's some shared data between all of them. Now let's suppose I want to find an object by a certain key. Let's say I want to find my default paragraph style. I start looking for that paragraph style in the file database, but if I don't find it, I then fall back to the shared database. We've built on top of this and some other logic this idea of like kind of cascading style system, where you can define kind of object references that may be resolved into your file, or something that you actually got from this template, or some state that is actually stored in this shared database. Another more complicated case out of this is what we call effective properties. So effective properties are ones where we go through a kind of, let's say I'm in a leaf of a tree, and I start looking back on a certain property value. If I didn't have that property value, I'm going to look it up in my parent. If that didn't have it, I'm going to look it up in this parent until I've at the root of the tree. And again, this is something that you can use for any kind of model object inside this graph. Just some baked-in runtime magic that's included in there. There's also visitors. So you can, for instance, let's say that I want to deep save a certain clique of my database graph. We try to limit, for instance, in certain cases, the frequency at which we call save on this data, so that we don't keep making for every single property update a new revision. So we would have some logic that kind of tracks whether certain parts of the graph are dirty, and then save all of the data that is reachable from that object in the graph. So that's something you would get from here as well. Another thing that the model object gives you is the ability to kind of track who did what. So if this is a collaborative tool in some form, it's quite handy that your model object already includes the idea that of like an authorship, that there's for instance, a creator for each one of the objects. We also know in which order people have touched all of the objects in the graph, and you can query things like, get me all the authors contributing to a certain paragraph, get all the contributions of a certain author in that paper, or get me the author who most recently contributed to a certain piece of content in that document. So it applies to any kind of model objects in that model. Pasteboard support. So this is maybe one of the things where you can think of a Mac a bit more than just like a big iPad. So this, where we really wanted to do some Mac-specific customization. So there's some NS Pasteboard writing and reading support for each one of the model objects as well. So we've implemented drag and drop support using this. So I can just drag and drop a reference to a certain object, and it will resolve it in an accurate way, even if I've got multiple versions of the same database open with the same revision of the same document that I put onto the pasteboard. And there's also some drag and drop specific helpers in the repository as well. It tends to be a pretty common thing to do. The HTTPListener, there's a small helper for that inside this package controller class. So package controller is kind of like the root object to which you put your repositories. And the idea is that package controller is the one that actually owns also the HTTP listening. So we've got logic there for opening the port. If that port wasn't available, then just try a few, back off and try again a couple of different ports. In terms of the data bundling, there's a few things that I wanted to go over. One is this idea that you've got some initial state that you can set up to your database. So you can bundle, like for instance, a certain JSON file in your application, and then just implement a certain callback function. If the callback function tells you that this certain file is available in the database package, it's just going to load up those data files, assuming they're going to be of a certain type, of the type of the repository that included that callback. So there's a helper for that. You can also put in a Couchbase Lite database itself inside the bundle, and you can either replicate it to that application support database that is inside there, or you can just copy it in there. So in some cases, that replication tends to be quite slow. So we have pre-computed instead, like the version of the database that needs to be bundled in instead of you replicating it in. And there's a distinction that is given between some initial state. So every database will get this state, or something that is a placeholder, something that's used, for instance, for like let's say your untitled option instead of something that is created based on a template. So there's like an ensure initial state initialized and ensure placeholder content initialized, I think were the callback names. Yeah. In terms of saving, I mentioned already that there's an idea of the contributor who created a certain document. There's also an idea of a session. So you can imagine, for instance, that in this architecture where I had some of the data being changed by the Couchbase Lite logic in Objective-C, and some of the data being changed by the WebKit side. Sometimes I get into a situation where I need to resolve, did I make this, or was it the other party? And depending on that actually influences my conflict resolution policy as well. So that's why we got this idea of sessions, and optionally that is struct for all of the different objects. So you can make a distinguish between the changes made by different devices, different parts of your application, different people who made it. I'm just going to mix this, skip this because I don't think this needs any more. So the idea is that you can automatically implement a part of your data model with these mixins. So that deliverable here corresponds to quite a lot of different kinds of state that is needed for a certain thing to be considered a deliverable. So there's many kinds of unrelated objects in our object graph that are deliverables. Yep. In terms of bundling the data, so I mentioned stapler. So stapler is something that takes in a series of JSON files describing documents that you want to load up, and optionally is an attachment data, and then kind of puts those together in a Couchbase Lite file somewhere. So these commands are something that we run quite a few of them in our full release builds. There's also a grep tool, actually, that's included there. So like a command line tool that you can use for just filtering some of your data. It tends to be quite common task that you need to figure out that actually, was this the state of my data that I actually saved on disk, or are these objects by certain keys actually available there? So we wrote a certain small command line tool for that. And the really final thing that I wanted to show out of these helpers that we have built is scriptability support. So there's a category that's given on the model and the repository object that lets you kind of find this in an Apple scriptable kind of Apple script context. And the second more significant thing that we built actually is a validator for this scripting definition. So, I mean, there's probably like one other person in the room who knows how Apple script works, but basically what you need to do for scripting support in Mac applications is to provide like an SDEF file, a scripting definition file that maps all your different properties in your different objects that are available in the scripting context. And the level of error handling that Apple has given for this case is, well, limiting. So we built something that actually will check early on during startup that whether your scripting definition looks all right, and whether let's say the key mappings and all that stuff is actually corresponding to reality. So this may seem like a complete kind of irrelevant detail. That why would you ever build it? Well, because no one uses AppleScript, right? But actually, for this kind of application, they will, because citation support, for instance, if you want to support inputting citations from somebody else's reference manager, this would be the way to do it. But there's actually a more kind of generic use for the scripting support as well. It's not trivial, but it's fairly easy to build, actually. And actually, for instance, with tools like Script Debugger, which I'm showing here as a screenshot, it tends to be a really good way of actually just navigating around in your data, just drilling down on this is what my kind of model tree looks like, and this is the state of things. I can modify data for things that doesn't actually even have any kind of user interface to it yet. And just kind of verify that things are as I expected them to be. But yeah, this was what I had. So you can find the code here at feather.kit. There's actually also a blog post at blog.manuscripts.ab that's related to this as well. I'm happy for any kind of questions. Yeah, go ahead.
So since you just mentioned the Apple scripting stuff, what was the reason you gave to do your error checking? What was the issue for having your package?
Well, the very basic thing is that you have to input these 4-byte codes for the different properties. They give you no checking that they're actually unique. It's crazy, like it's like an old remnant, really, that they're there. So these Apple event codes, they're not unique. We also do some type checking to say that a certain property name actually matches your property type in your class as well. Yeah.
Does Feather support any access control or role?
Sorry?
Does Feather support any sort of user access control or role?
No, we haven't had the need for that yet, but we would, this actually on our roadmap anyway to build it, because obviously you'd want to, let's say, this section can only be edited by a certain contributor. So we're probably going to put that into the validation level, at least in this framework, and not just in the application that we're building on it. Yep.
How easy is it to bundle Feather to use in other frameworks, not just in this scenario?
You mean with different backend, or?
Yeah, or either different front end. Like, what if you wanted to open source or release your product to the Android market so that you have more exposure? How would you do that?
Android, I haven't honestly thought about much, but there's nothing very complicated about what we serialize, for instance, in those objects on top of what Couchbase Lite would itself put. So we have a convention on what the object IDs will look like. So they are prefixed with the type. It just makes, again, debugging a bit easier to find that I've got big chunk of documents and which one is what. And then there's another object type field that is required. So it would be very simple for somebody else to write something that deals with the data in the same conventions as what we do. Anything else?